Hey everyone, welcome back to my channel where we dive into the world of IT and DevOps. I am Ajan and today we are starting a brand new series on Kubernetes. Kubernetes has become a crucial tool for managing containerized applications in the cloud. But what exactly is Kubernetes and why is it so important? Let's find out. This series will solely based on hands-on tasks. First two videos will be a little theoretical background, so bear with me for the first two videos. Kubernetes is an open source platform designed to automate deploying, scaling, and operating application containers. It was originally developed by Google and is now maintained by Cloud Native Computing Foundation. But before we dive deeper, let's break down some basic concepts for which Kubernetes is required. First, let's talk about containers and microservices. Containers are lightweight, standalone, and executable software packages that include everything need to run a piece of software code, runtime, system tools, libraries, dependencies. They ensure that your application runs smoothly in any environment. Whereas microservices, on the other hand, are an architectural style where applications are structured as a collection of loosely coupled services. Each service represents a functional, or I will say a business functionality that can be deployed, developed, and scaled independently. Now, you might be wondering why we need Kubernetes. Managing containers can get complex, especially when dealing with multiple containers across different environments. Kubernetes helps solve these challenges by providing a framework to run distributed systems resiliently. Basically, there are some key features of the Kubernetes. Firstly, is the scalability. Kubernetes can scale applications up or down based on the demand. Self healing. It automatically replaces and reschedules container that will fail or suddenly any containers if it goes down, it brings up the pod. We will discuss what is pod and what other terms are associated with Kubernetes in just a while. Third is service delivery and load balancing. It provides a built-in mechanism to discuss services and perform load balancing. So, I think before we go much deeper into the Kubernetes and the hands-on, we should know few of the terms that are associated with the Kubernetes. In next 2 minutes, we will go over this flow diagram and this architecture. Before that, I would like to tell you about some of the terms that we should know before discussing this flowchart or architecture. Okay, so first let's talk about the pods. A pod is the smallest and simplest Kubernetes object. It represents a single instance of a running process in your cluster, and a pod contains one or more containers that share the same network namespace, IP address, and storage. You should know that pods are ephemeral by nature, which means that they can be created, destroyed, and recreated frequently. Kubernetes ensures that the right number of pods are running at all the times. Due to this ephemeral nature, pods are always given a new IP address on creation. Next, let's discuss services. A service is an abstraction that defines a logical set of pods and a policy by which we can access them. Services basically is to provide a stable endpoint for pods, enabling load balancing and service discovery. Okay, so the third thing that we need to know is Ingress. Ingress is an API object that manages external access to the pods or to the application from the outside environment. Basically, it handles the HTTP or HTTPS request and we can create a routing rules to manage traffic to your application. Next, the most important two things which are config maps and secrets. Config maps are used to store non-confidential data in the form of key value pairs, whereas secrets are used to store credentials required for accessing either front end or a back end of the application. Last but not the least, in this flowchart, you are not seeing volumes over here, but there is a concept of volumes. Volumes provide a way to provide a data across pod restarts, basically to persist data whenever a pod restarts. Kubernetes supports several types of volume, including empty directory, host path, network storage solutions like NFS. Basically, in a nutshell, volumes ensure that data generated by containers is not lost when the container stops or it's restarted. Okay, so these are the few terms that were required to be known for discussing this flowchart. So if we see this a broad architecture and the components. So in the layman terms, I will say this is a broad architecture of a Kubernetes. It's not a proper architecture, but it includes the flow and the components that are associated with the Kubernetes. In the next video, we will discuss the actual architecture of what all things are included in the master node and what all things are included in the worker nodes. For now, for this video, we will discuss this. So in a broad terms, there are two things in the Kubernetes that we need to know about it is the master node and the worker nodes. There can be a multiple master nodes, and for each master node, there should be at least two worker nodes. There can be a one worker node, but it is of no use. I will tell you in a bit why. So for example, if we are dealing with any complex applications which have many components, many dependencies, in that case, we will require more than one master nodes. But I must say that handling multiple master nodes is quite difficult and quite complex. For now, so let's discuss, for just the sake of discussing the architecture and the flow of the Kubernetes, we will take an example of one master node and two worker nodes. Okay, so basically master node is can be used as an orchestration or to orchestrate the two worker nodes. Anything that you want to deploy on the Kubernetes, you, your application will get deployed on the worker nodes associated with the master nodes. So if we come to this worker node, you will see the pods. There are two pods. One, as you know, like the applications are very complex on the corporate level. So there can be a front end, back end, many other files and file systems for the application. For now, we will take the two important things, which is a front end and the back end of the application. So in this example, we have hosted a front-end application and the back-end application in a separate container and spin up on the Kubernetes in the form of pods. So these are the pods, and it contains the containers of the front-end application and containers of the back-end application. Now, for each pod, we should have a separate associated service with it. So I have created a service F1 for the front-end pod and service B1 for the back-end pod. These pods are associated with the service. For each pod will be associated with each service. So why this is needed, why service is needed, is because whenever in case of any failure or any crash, if suppose one of the pod goes down, then as soon as Kubernetes brings up that pod, it will assign a new IP address. So every time when a pod is getting created, a new IP address is being generated, which is not useful in communication between the pods. So what will happen if backend needs to access the front end? So in that case, if every time IP address is changing, how the backend and front end can communicate? For that particular reason, we have the service, and service has the fixed IP address. So because of that fixed IP address, service F1 can communicate service B1 and vice versa, and ultimately pods can communicate with each other. Moreover, apart from communication, service also provide a load balancing facility. So if any external request is coming to your application, it will be handled by the service, and according to the traffic and the volume, it will be directed to the pod. Okay, so next thing that we need to see is the backend of the application is connected to the two things, which is a config map and secrets. As we already discussed, ConfigMap is used to store non-confidential data. For example, suppose in backend you have a database, and for accessing a database you require an API endpoint or a URL kind of thing, which is not a credential or not a confidential data. So for that, you can store that thing in the config map. So why we are doing this is because to maintain the modularity of the application. So suppose in case if you want to make changes in some backend pod, you don't need to worry about the values, the configurations that is non-confidential and which is stored in the config map. Secondly is the secrets, and secret is just to store the confidential data like credentials. For example, you want to access the database, the Kubernetes can pick the credentials of the database from the secrets file. Now, you can ask why the same thing is being replicated over here. So when we are deploying our application in the Kubernetes, our intent is to maintain the availability of our application. How we can maintain the availability is to create the replicas of our application. So whenever you deploy with two or more replicas of your application, Kubernetes will take care by itself. So one of the replica will be hosted in one worker node, second replica will be hosted in second worker node, and if we have more replicas, for example, we have three replicas, it will divide it accordingly. So first replica will be hosted in one worker node, second in second, then third in again first worker node, and so on. And accordingly, you can add more worker nodes to the master nodes to make it more available, to make your application more available. So this was an overview of the components, or I will say the terms that are mostly associated with the Kubernetes and which we will be using in our hands-on experience or hands-on video. So for now, the next video will include the architecture of the Kubernetes, basically architecture of the master node and the worker node. And after that, we will start with the hands-on tasks. So thanks everyone. Thanks for watching my video. Bye for now.